Good evening, fifth graders. Tonight we're going to be stepping it up a notch. We're going to be working with some mixed numbers with our fractions now. So we're not just finding parts of a whole. Now we are taking a whole number and adding it to a fraction. So let's take a look at some of these examples here. First off, we're going to do some mental math, okay? What is a fraction of an hour? So all of our denominators would be 60 here. So 30 minutes would be 30 over 60. 45 minutes would be 45 over 60. 10 minutes would be 10 over 60. Once again, we're not reducing yet. 15 over 60. 50 over 60. 40 over 60. Okay. How many hours is 120 minutes? Okay. So we're dealing with 120 minutes. What would that be? So this is what the new stuff we're looking at here today, okay? We'll extend this a little bit. So this would be 120 over 60. This one would be 150 over 60. This one would be 90 over 60. And then 75 over 60. The reason why this is new, kids, is the numerator is bigger than the denominator. And we don't really want to leave problems like that, because this is called an improper fraction. How we can get this smaller is we have to see how many times the denominator can fit into the numerator. So how many 60s go into 120? Well, exactly 2 60s, because 60 times 2 equals 120. So your answer is 2. So how many hours is 120 minutes? It's 2 hours. 150, 60 goes into 150 twice. But what is the remainder? Well, if 2 60s equals 120, 150 minus 120 would be 30 over 60. So does this make sense? 150 minutes, how many hours would that be? That'd be 2 hours and 30 minutes. Take a look at this one. How many 60s go into 90? 1. What's left over? 30 over 60. Does that make sense? 90 minutes would be an hour and a half. It sure does. How many 60s go into 75? 1 goes into 75. What's left over? 15 over 60. So your answer is 1 hour and 15 minutes. That's all we're doing today. We're just breaking a mixed number into an improper fraction, I apologize, into a mixed number. Take a look here. So we're going to be dealing with an hexagon, a trapezoid, a rhombus, and a triangle today. And we're going to be breaking it apart so it can be, excuse me, so it can be a little more simple. So taking a look at this page, don't worry, this looks a little complex. I'm going to make it even more simple for you, okay, when we get there. First of all, as you can see here, we're going to make each one of these improper fractions. This is how you do this, kids. This is called a mixed number. When you have a big number and then you have a fraction, this is called a mixed number. I have to make an improper fraction. So what they want you to do is to put this 2 back into the problem. This is how you do it. It's kind of like a clock, okay? You're going to multiply, then you're going to add. So 7 times 2 is 14 plus 3. 14 plus 3 equals 17. And then you just keep the same denominator. I'll do another one for you. 8 times 7 is 56. Plus 3, so times plus 3, 56 plus 3 equals 59. So your answer is 59 over 8. Let's do another one. 2 times 4 is 8, plus 1 is 9. 9 over 2. 5 times 10 is 50, plus 4 is 54 over 5. We'll keep on looking at some examples down here. 6 times 3 is 18. 18 plus 8 equals 18 plus 8 is 26. 26 over 6. And this is how you can check to see if you did it correctly, kids. How many 7s go into 17? 2 7s go into 17. 7 times 2 is 14, so 14 minus 17 would give me 3 7s. You see how that's the same number as we started with? How many 8s go into 56? 7 do. 7 times 8 is 56. 59 minus 56 is 3 8s. How many 2's go into 9? 4 2's go into 9. What's left over? 1 half. You see how these are all the same. How many 5's go into 54? 10 do. What's left over? 4 fifths. Last one, how many 6's go into 26? 4 do. What's left over? 6 times 4, 2. 2 6. Now this one's different, kids. I didn't do it wrong. Why is it different? This is why. because we had a mixed number, but take a look. This right here, the numerator is bigger than the denominator here. So right here, you had a mixed number and an improper fraction combined. That's what made that one a little mixed up. Okay, this is how you would completely reduce it though. Take a look at some problems here. So you're going to see a rule as a hexagon today. So the rule is this equals 1. So what would a triangle equal? Well, this is what we're trying to find out. How many triangles are in this hexagon? 1, 2, 3, 4, 5, 6. So this triangle equals 1, 6. This rhombus equals 2, 6. Because there's 2 triangles here. 1 triangle equals 2, 6. So this would also be 6 over 6, which would equal 1. Because how many 6's go into 6? 1. So that's why it's 1. Okay. Take a look here at this trapezoid. There's 3 triangles here, so this equals 3, 6. You're going to be doing some problems today that look like this, and I'm going to keep on showing you some examples of how this works. Okay. Here's another problem here. So a triangle equals 1/4. So if one triangle equals 1/4, how many triangles are in this shape? We have 1, 2, 3, 4, 5, 6 triangles. Okay. With 6 triangles there, that means I would have an answer of 6 over 4. Because I have 6 triangles, each triangle is worth 1/4. That means I have to add up 1/4 plus 1/4 plus 1/4. I have to add it up like that. That's how I get 6/4. But when I'm making this a mixed number, I have to tell me how many 4's go into 6? 1. What's left over? 2 4's. So another one here. So now the triangle equals half. Well, how many triangles do I have in here? I have 6 triangles in there. So that means I have 6 over 2. Because I have 6 halves. So that's working with the math today. So we have 1 half, 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 half. 6 times, okay. How many 2's go into 6? 3. Your answer is 3. Let's take a look at this problem. This is kind of like the problem here above. So I'm going to take this. I'm going to delete this. Take a look at this right here. I got 3 of these, right? 3 halves would be 3 over 2. What would this be as a mixed number? It would be how many 2's go into 3? 1. What's left over? 1 half. If I multiply 2 times 1 plus 1, would I get 3 over 2? I would. That's your answer. Okay. The hexagon is 1 whole. So I have 1, 1, so I have 2. I have 1, 2, 3, 4. This would be 4, 6. Okay, because each one of these, because I know a hexagon has this many, this many triangles, 6 triangles. So I have 4 here, 4, 6, 2 and 4, 6. What would this be as an improper fraction? 6 times 2 is 12 plus 4, 16 over 6. These are my 2 answers. You're gonna have to come up with 2 answers today. Take a look here. How many triangles do I have, or how many hexagons do I have here? Well, if I'm looking at this hexagon right here, I have 1 trapezoid, I have another trapezoid. So I have this one and this one. This would equal 1 whole, if a hexagon is 1 whole. And then right here I have 2 triangles, so I have 1 and 2, 6. Is it also written as 6, 8 over 6? Now, I think I have enough time to show you this last problem, okay? You're going to see a problem like this today. Here's your rule. A triangle is 1/4. So I'm going to take a look at this shape right here. I'm going to break this apart into triangles, okay? Okay, here's another one. Okay. Everyone see how I broke this apart here, okay? This is one thing I want you to realize. 1/4. I got to see how many fourths I have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16 over 4 as my answer. You're going to see a problem just like this in your assignment tomorrow. And you're going to have to break it apart into triangles. You have to find out what is each triangle worth, okay? In this situation, they had the value of the triangle at 1/4. All they're trying to have you do, kids, is add up fractions. I know it seems kind of confusing. Every year when I teach this lesson, it gets kind of confusing. But if you keep in mind what the rule is for the problem, and you're going to see it tomorrow, then you're just going to have to do the math by counting the triangles, okay? So if I have 16 1/4, That would be 16 fourths. Next thing I'm going to ask, how many 4s going to 16? Exactly 4 going to 16. So your answer to this problem, kids, is 4. What I don't want you to do is get confused with how this is working, because all you're doing is you're working with fractions and you're adding fractions up. The main point of the lesson today is converting a mixed number into an improper fraction and an improper fraction into a mixed number, which looks a lot like this page right here. If you understand everything on this yellow page right here, that is my main concern for tonight's lesson. And then tomorrow I'll be able to work everything through with you. But I just want you to keep in mind, I'm going to show you one more example since I have 20 seconds. Let's say I have 6 and 3/4. What would this be as an improper fraction? Well, you're going to have to multiply first, and then you have to add. 4 times 6 is 24, and I have to add this 3, which gives me 27. 27 over 4. Then when I work backwards, kids, this is called an improper fraction. Now when I'm making it a mixed number, I have to ask myself, how many times can this denominator fit into my numerator? 4 times 6 is 24. 24 minus 27 is 3/4. Hopefully that helped your assignment. I know I went over by about 20 seconds, but please forgive me. I will work very hard with you tomorrow in class, and I look forward to seeing you tomorrow. All right, good luck.